Hello, I'm Efraim Grynberg, Vice President of Sales Engineering Solutions Engineer Field Engineering here at WEKA, and I am here to talk about WEKA on Converge on AWS. Okay, so as Phil and Brennan was talking, one of the things that we want to provide to our customers is flexibility of deployment that match their business goals, their technical issues, and economic targets as well. And this is one of the ways that we can provide. Now, what is Converge? We didn't invent that term, and probably you already know what it is. We are running the WEKA software on the same servers that the application is running. Okay, that's Converge. I think there is no need to expand on that. We are actually WEKA, and you will see, we are going to take a very small portion of the resources available, okay? And that is where we are going to run our software. Why we want to do it? Well, very simple. It provides significant cost savings, okay? The underline to that cost savings is that also saves a lot of energy. It's a greener solution. In the cloud, it's difficult to measure, but we can do that. And as you have more scale, that will be much more valuable. Now, do we want to use Converge everywhere? No, but if we think about targets, large GPU farms will be a good example. Also, when we have resources that are underutilized, okay? Or on the flip point of it, if you have a resource that is overutilized, actually, and most of our customers, what will happen, they have GPU farms, okay? They are overutilizing their GPUs, but not so much CPUs. Now they want to buy more GPUs, so we let them, with this model, to use the money that they would use for storage or infrastructure for storage to invest on GPUs, and we can take even more of the other resources that are not utilized, okay? Questions clear? Great. Okay, let's go and dive in a little bit on what we call a dedicated mode for WEKA, okay? This is another view of the slide that you saw previously. We have two different EC2 groups, you can say. One is running your application, can scale out, can scale in, depending how did you program that. And you have EC2s, the i3 instances that we mentioned before, to run the WEKA software. And it's separate one from the other, independent. You can scale out, you can scale in, you can tier to an S3 bucket and expand the namespace of your file system. If we dive into the i3 instance, what we are saying, so there is I am taking here, by the way, an example of an i3 EN6X large. The reason I am taking that example is because it's the minimum, it's the lowest kind of tier of this instance that guarantee you bandwidth, 25 gigabits per second. Other smaller instances, we can use them, but you don't have bandwidth guaranteed, can affect performance. So the maximum number of ENIs, NICs, that you have in these instances is 8. That actually will be our limiting factors. 24 cores, 2 7.5 NVMEs. That's very important for us. We are storage, we need those. And memory and things. What are the resources that we are taking? We are trying to take as many resources from these instances. We are in dedicated mode. We want to be greedy. Our limiting factor actually here is the number of ENIs. We pin one NIC to one internal process of WEKA. That's part of the optimizations and bandits on how we increase performance, okay? So we are using only 7 cores out of the 24. There is a breakdown on how, but we are using both NVMEs because you don't use those NVMEs for operating system. You have other disk, and we are using as much network and as much memory as we can use. Doesn't mean that we need it, but we are in greedy mode. We don't have any competitors here, right? So now, that's not a lot and provides a lot of performance. By the way, this can give you 1 million IOPS and a lot of throughput, and enough throughput. We can take advantage of all that bandwidth. If we have, depending how many instances we have, we can scale on throughput, on IOPS, and things like that. Now, why we can now do Converge? let's dive in actually how the P4Ds of the P5D instances look like. They are much more powerful. They are a lot of resources. There is a massive densification of resources in instances. So the P4D instance, if you are not aware of with it, is kind of an instance with an NVIDIA GPU. It's the NVIDIA A100. There are 8 of them, actually. And these are the most available ones right now. Like if you are not familiar with NVIDIA, or if you are, like the A100 and the H100 GPUs are top of the line for NVIDIA, is what most of our customers use to train AI ML models or do drug discovery, others. H100s are not so much available. They are the newest, but they are not so much available. Even for the P5D, AWS doesn't have a price list. P4D is what most of people are using. So I am going to use that example. But again, you can use the P5D, of course. So if you look at the resources, are huge. Okay, we have 96 virtual CPUs. If you remember before, I say that we can use 7 or 6 even. There is 1 terabyte of memory, RAM, on that instances, 8 NVMEs, a lot of bandwidth, okay? So we can actually go and say, we want to take a very small portion of that, very small portion, and create a WEKA cluster on those CPU, on those same GPU servers. We don't want to have you to spin up i3 instances for that. Give us a little bit of resources. Again, in this example, and this example is a real example that the customer is using, okay? I am not coming with the numbers. So again, from each one of these instances, and let's say that we use 8, right? We don't use the GPUs for our software, that we leave to the application. We are going to use actually 6 cores here, okay? 7 of the ENIs, and there are EFAs, which is a newer type of network card that AWS provides, those what the application will be used, and only about 24 gigabytes of RAM. If you remember, in the i3 EN66 large, there was 192. We use as much as possible, but we don't really need it. We can deal with a very small. So less than a 10%, and we can create a WEKA cluster. Now, just to give an example, let's say 8 of these nodes, and our customers are using hundreds, we are going to show. Only 8 can give you, we did a few tests last week, can give you 35 gigabytes per second, okay? Only 8, you can scale it. It can give you, we saw, 1 million IOPS. And that's a lot. Okay, that's a lot. If you talk about on-prem, doesn't sound a lot. For AWS, it sounds a lot. And we are not using a lot of resources. If you scale, our IOPS and our bandwidth and metadata operation scales linearly. The more nodes you do, the more you have. Now, let's say that you have 100 of these. You can do the math on what is the performance you can get, taking a very small amount of resources, okay? That will save a lot of money, as I will show, but also saves a lot of power. It's a very green solution because those instances there are still consuming all the power they need. And what we see on our customers on-prem or on the cloud is that on those type of things, they are generally maximizing GPU utilization. Not always. They have, actually, we help them doing that. They have a lot of problems, or not problems. They don't need so much CPU, so much memory. Okay? Now, a little bit of comparison on economics. If I look at the AWS offerings, from my point of view, if you want to run an HPC workload, or if you want to run a AI/ML workload or performance-intensive workloads, these are more or less the offerings that you have. You have FSx for Lustre, which is the native offering, good offering. Now it's Lustre. It's very good at throughput. Other things, not so much, but it's okay. you have WEKA on dedicated mode, and you have WEKA on converged mode, as we say. And what we want to compare here is not performance, but this is price. We say that we charge on capacity. So we are doing 100 terabytes of Lustre, 100 terabytes of WEKA dedicated, 100 terabytes of WEKA Converge. And these are the pricings. Now, FSx for Lustre has 5 tiers. I am using, for the comparison, the lowest and actually 4 tiers for here. The 5th is not considered, is not resilient. It's only targeted for scratch space. So to make sure that I do apples to apples or as much as possible, I am using the lower tier of the resilient solution and the higher tier of the resilient solution. Lower tier and higher tier is based on performance. And what we are seeing is that the lower tier gives you 175K per year and 720 if you need the higher tier. By the way, the performance of these are measured on throughput on the AWS Marketplace. They don't publish IOPS number. At least I couldn't find them. So again, we can give more throughput or similar throughput, but much, much more higher IOPS and metadata operations, which are super important for any AML workload, or any workload that actually is using GPU, okay? You can see, well, so the 100 WEKA all-flash, again, I used the same instances that I showed before, i3, EN6X large to measure. You need 11 of these instances. I did the math. So if you're going to get to 100 to those 11, the infrastructure cost of those instances will be 270K per year, based on AWS Marketplace. No discounts, nothing. The WEKA all-flash capacity is about 100K. Okay, it's not about, it's 100K. Okay, again, as we publish that on AWS Marketplace. Okay, I want to, all those are published numbers. This gives you better performance than the lower tier, and is significantly cheaper. And we are talking only about 100 terabytes. Imagine this on petabyte scales, okay? And it's a little bit more expensive than the lower, but better performance, but it's significantly lower than the higher tier, okay? And you can go to Converge. Again, you don't have to pay for the infrastructure. With the P4Ds, because of the capacity of in the NVMe, I needed 24 of these instances because I use only 6 drives instead of the 8 drives. Okay, so we get, again, WEKA for only 100K. Now, the performance of this is comparable, I think, at the high performance of the FSx Lustre. And this is only using 22 of these instances. As I said, we are going to show we have customers using hundreds of these instances where WEKA is deploying this way, okay? And the performance that you can get is on the hundreds of gigabytes per second and tens of millions of IOPS with very, very low latency. The energy cost saving for AWS, you pay, the customer don't get that, but if you want a greener world, you can think about that, it's massive. Okay, is this type of deployment a good deployment for every place, every workload? I mentioned this a little bit before. You want massive instances, okay? And also, the other thing is that, okay, what are the things? We have very good cost optimization, better value at scale, but what you need to consider is that you have a little bit of more complexity, right? You are running your storage and your application with different resiliency models, okay, maybe on the same hardware. Now, if you don't have good citizens that go and log in into your instances and start rebooting servers or doing like that, that won't be good for your data. Okay, we can take snapshots and make sure that you have snapshots on your object store and you can recover them, but you don't want interruptions, you don't want to lose data. So these are the considerations. You want to make sure that you restrict root access, that you have a good change control, okay, policy, that you are in an orchestrated environment. What means orchestrated environment? People that are using Slurm, so users are not running jobs directly from these nodes. They have nodes outside that all the jobs are orchestrated through Slurm. Kubernetes environments, by the way, are pretty good because the worker node, nobody touched them. You have a DevOps team that is actually using them. And someone, I think you before talk about failure domains, okay? We have in WEKA the concept of placing some of our instances in failure domains. Like if you think on-prem, different racks that you want to protect because electricity, the same concept here. Now if you can align your application failure domains with your WEKA failure domains, then all the upgrade process is much more easier because you can do some kind of rolling upgrade and you don't have, or maintenance, you don't have any problems. So there are some considerations. Large GPU farms, I want to believe most of the customers will already be in this stage, right? If you have hundreds of GPU servers and hundreds of users that are trying to run jobs and you don't want to collide one to the other, you need to have this orchestration. So what we see is not a friction, but if what you are doing is now you need to start, run, and then you will fix problems, this is what is important for you right now, don't start with Converge. Probably not a good idea. This is a great solution for mature companies that are investing massive cost on AWS. So again, flexibility, cost optimization, saving energy.
Who's your ideal user? So somebody that's going to spend their day in, or send a portion of their day in WEKA.
So the ideal user for this?
Yeah, like somebody who would, as we know, with any technology product, if you go to the CEO and ask them what products to use, no idea. Go to the CIO, maybe they know, but they'll likely know the cloud provider. As we get who's actually
that's a great
doing
question.
Amazing things.
Yeah, that's a great question. I don't want to name the customer. We are going to name it because it will be spoiler alert. But all these customers that are doing LLMs, AI, that they have incredible, amazing GPU farms. They have a lot of money right now. They are trying to buy as many GPUs as they can, and that's where they want to use their money, in GPUs. Those are the things that they need. We want them to spend money in storage, but only what they need, and this is a great solution for them. Okay, this is a great solution. Also, research institutions, by the way, in on-prem, things like that, they have a lot of GPU farms. They are great customers, and again, since they have many users, so they really need that orchestration layer that they already have, and we can save them a lot of money.
So the idea is really sort of like unstructured data, AI, ML, obviously clean use cases, stuff like we talked about VFX, like high throughput, processing, really susceptible to heat problems and throughput problems.
So
what about raw, like transactional database workloads sitting on top of it? Do you have it, and is there performance advantage?
So I talked about containerized workloads, right? Now, what you don't put in generally an OLTP database in WEKA that is running on-prem. You can do that, but in general, there are other solutions that are good and with a lot of features like a consistent snapshot for that. What we see is that there are a lot of companies that are containerizing all their workloads, and everything is container, including database. And here, WEKA is great. Actually, we didn't a great solution. We didn't look for those customers. Customers start using the existing containers databases. You provide a very good. We have a very strong CSI plugin. Okay, that can support many users, many applications, many pods. And you have also very low latency. WEKA is a shared file system at the end of the day that supports very low latency, even lower sometimes that block storage. And then for those use cases, this is excellent. Like Kubernetes is great.
Do you present the extra features directly through the CSI, like snapshotting and other primitives? Because some storage players don't expose it necessarily to the Cube management API, but it's managed on the WEKA or whatever.
So we are improving our features and CSI plugin all the time. Snapshots you can do now on the Kubernetes level. You couldn't do that a few months ago, and now you can do. And there are some of the other things, like we don't encrypt right now per container. We encrypt on the file system.
Right.
But we are including that.
Trust me, if you can solve that problem, the whole world will be in a different place by the time we solve that problem. You'll get there first, but
we will. We are close.
So
I have a few questions that I would also like to pop in before we reach the end of the session, because you have been mentioning the green solution and kind of the sustainability aspect of it.
Mm-hmm.
So I feel like I need to bring up a few questions here regarding that. This is really great that you are bringing this up, and I see that a lot around sustainability aspect that you are mentioning is kind of focused on creating a very resource efficient performance solution and minimizing the amount of resources you're utilizing, which is really great.
Mm-hmm.
And you mentioned that you are measuring it is difficult to get this data from the cloud providers, but you are performing the measurement of for instance, carbon emissions. And I'm curious, how are you kind of measuring that?
Yes, we have actually an external study that an independent company ran for us. I don't, it's street, right?
Yeah.
Anyway, there is it's not on cloud. As I say, in cloud it's different, but we have customers on cloud and we have customers on-prem, and doing some of the extrapolations and measurements, we can extrapolate how much of that we are saving for similar workloads.
So you're running comparison with kind of similar solutions and providing the data in terms of carbon emissions, you say, for instance.
Exactly. Yes. And the numbers that Phil showed before that I don't remember by heart.
260 tons.
Yes. And based on that solution, on that study that we did, and it's public in our website.
It's publicly available. Will
Yes.
you be able to share that information?
Yes.
Afterwards?
Mm-hmm.
Thanks. And I have one more question as well. Since you mentioned the pipelines and kind of how you are working with redundancy and also choosing the regions, I see some potential here in terms of carbon aware solutions, both in terms of when the workloads are running and which regions you choose to run, for instance, those data pipelines. Is this something you have been looking into, like in terms of advising the customers? Is it like something you have been looking into? Or in terms of the regions you choose?
From a carbon emission perspective?
Yeah.
That's actually super interesting. No. The answer, I think it's no, but it's super interesting and we should.
Okay, maybe we could discuss that, because I am involved in multiple organizations that are working with specifically cloud native sustainability and carbon aware cloud solutions. And I think there is a potential here where you could also help on that aspect in terms of, for instance, when you're training when your data pipelines are running, like running when the energy is cleaner versus running more when the energy is cleaner and running less when the energy is dirtier. So this could be an interesting use case based on your high interest in sustainability efforts in this space.
You are going to get a phone call or mail or whatever. That's
yeah. Okay. Okay. Cool. Thank you.
Thank you.
So I want to give an opportunity to address kind of not necessarily an elephant in the room, but maybe a slightly large mammal who we have yet to address, which is kind of like I wanted to use AI and ML, now what, right? So you mentioned most people are immediately going to think, I need GPUs, and they're going to run out and try to gather up as many GPUs as possible. They're trying to try to grab as many GPU-enabled instances as possible. At what point does that customer kind of stop and think, and going back to that first slide, what about the data? And then ask that question. And how do you guys respond or kind of position yourself for that customer?
So they generally don't think about the data at the beginning. They come and in most of the cases, what we see is an afterthought. And we are here to help them, okay, how you actually now think about data and how we can. The good thing is we provide a lot of advice on okay, if you have this type of data sets, and we have also slides with customers, with data that we really have on how IO workload look like. One of the things that we see that customers do is they size their data platform based on average IOPS, average latency. But what is important is the burst, right? What are you doing with the burst? In the cloud, it's easy. We can help them because, okay, you have a burst, or you know that you will have, just auto-scale your WEKA cluster, you will get more performance, also capacity, things like that. On-prem, we need to teach them exactly how to size, and it's part of what me and my team do a lot of it. So showing them real data that we know from other customers, letting them to talk with our other customers, have a lot of experience with that. So explaining them about resiliency. Okay, we didn't talk about here resiliency a lot, but we consider ourselves an enterprise solution, and we are fully resilient with failure domains and all those things that we need. Okay, that's another part, like, okay, how do you make sure now that you have all the power that you need, all the resiliency that you need? That's part of our conversations with our customers. I hope it answers your question.
Yeah, so I'm going to be a little belligerent here because I don't know a lot about AI, and I'm going to kind of be that type of person when I can go into this type of discussion. So the first thing I'll say is there needs to be some sort of statement before the problem presents itself, right? And most of us in engineering, we want to be ahead of the problem before we get to it. Not necessarily and a customer probably hates the idea of, when you have a problem, come see us. That's not really a great position, right? And so we want to make sure that we attack head on what exactly is the value statement that you can say, hey, you're going to run into this. This is how we solve this problem, and this is how we solve it in different ways. For instance, the bursting to cloud, the hybrid, and the sizing that you just presented are all great solutions. The resiliency you just brought up, fantastic to talk about. But resiliency of what? It's data. I get it, but it's data for AI and ML, and what's the secret sauce there that really makes an AI developer or CIO go, ooh, I really want that?
Yeah, so again, features, there is the slide with the triangle that you see at the introduction, right? Storage, you have compute, you have network, storage, never thought. So again, things that are very important for us to mention is metadata operations. Nobody think about that. We need to, they think about that when we come, and we are trying to do a lot of thought leadership and trying to teach the world that this is what you need to think about that. Not everything is about throughput. What I mentioned, AWS Marketplace, put everything on throughput, which I understand why they are doing that. IOPS is not something that people think, but our customers think a lot about that. That's part of the secret sauce. How do we have 69 already granted patents, and I don't know, it's a lot goes into that. How do we optimize how we distribute metadata? How do we make sure that you don't have to over provision for one of the metrics, okay, in your performance, okay, but you have actually also or specific workloads? How do you amortize all those operations across your cluster, and you don't create hotspots? This is the type of conversations that we have a lot of information. We didn't go very, very deep here on our internal architecture, okay? But that's actually how WEKA was born, exactly to solve those problems.
So basically, I guess the statement to that type of person is, you're going to run into, person, customer, whatever you want to call them. You're going to run into this problem. And we solve this problem by performance as well as cost optimization, as well as different form factors, as well as all these other things. But at the end of the day, you're going to run into this need of a lot of data. And it needs to be scalable data, it needs to be data that needs to be able to be moved and migrated and be agile. And Mr. Customer, we do all of that for you, and we're willing to not only help you, we're willing to size it with you, sit with you, and also be that trusted advisor in order to help you along the way.
Yes. So we are not, like as I said, we are looking for partners, if you name it, instead of customers, or at least it's how we, like, it's a long-term relationship. I think not saying that only for WEKA, I think any enterprise should treat their customers our partners and not only by customers. We have all that. We try to go, as you say, ahead of that. We work with our OEM partners so that they are selling all these GPU servers or all this compute to tell to the customer in advance. Think about the whole solution. Think about the storage or the file system as well.
That's actually not a bad segue just into the commercial model and the go-to-market. Are you guys working? You're obviously working with the customer directly a lot here, but are you going partner channel as well and looking down that avenue?
Yes, partners, channels. We work with all the major server vendors also as partners. They can sell WEKA.
Yep.
All the big partner channels in the cloud. Some of them.
Well, the cloud providers, the market teams themselves.
Yes.
Yep.
Mm-hmm. We don't sell anything direct, by the way.
Now, of course, in the deployment model, we talked about the deployment model today. It's not marketplace. Can you transact through the marketplace?
Yes.
Okay. Yeah.
Yes.
So that's a dumb question, but it's important as a partner because AWS.
Yes, and all the data that I presented in terms of pricing is including WEKA. I took it from the marketplace to be very fair and